Hi everybody, I'm Parth Patel and I along with my project partner Ishan Handa tried to identify and predict the impact of student alcohol consumption and addiction on academic performance as our final project in the course of machine learning. Alcohol use on campuses is a long established problem. The 2015 Youth Risk Behavior Survey showed that 33% of the high school students surveyed drank more amount of alcohol in the past 30 days and 18% of this involved binge drinking. This proportion has been decreasing slowly over the past 20 years as the result of education campaigns regarding the dangers of the underage drinking. Aside from physical, mental, and social problems associated with drinking, youth who drink are more likely to experience problems in school, such as failing classes or skipping school entirely, both to avoid overall poor school performance and for the sake of students' futures. Treatment is needed. In this project, we aim to classify the students by the likelihood to have drinking issues. After categorization, schools can direct the resources much more effectively for the purpose of intervention and prevention. These are some of the consequences of alcohol consumption amongst the students, which you will find in the reference of the final report.
Hi everyone, this is Ishan. So I'm going to talk a little about the dataset that we've used for this project. Our dataset comes from a UC Irvine machine learning repository. It was collected from across two public secondary schools, in which 1,044 supplementary survey questionnaires were submitted. It consists of some binary features like the gender, the school attended, urban or rural address, internet access, and numeric features like the age of the students, absences from school, course grades, and also some categorical features like mother or father's occupation and reason for school choice. The main features that we are focusing on are weekend and weekday alcohol consumption. It's rated on a scale of 1 to 5, with 1 being very low and 5 being the highest. To prepare our dataset, we've converted the binary features into 0, 1 values. For categorical features like uh, um, occupation, we've used one hot encoding. For our target variables, we've considered the weekend alcohol consumption above 3 as a positive value, and for the weekday alcohol consumption, anything above 1 is considered as a positive value.
So the models which we have implemented for this problem are knife Bayes as our baseline model. Next we implemented was logistic regression, and finally we came up with the random forest algorithm. We have split our data into the training set and the testing set in the ratio of 18 is to 20. So these are the metrics which we obtained by implementing the Bernoulli's Naive model from the scikit-learn library. This was implemented using the default parameters. None of the hyperparameters were changed. To improve upon our naive model, we changed the value of alpha and we got promising results. So we implemented the model for various alpha values, and the one which gave the best results was alpha is equal to 5. As you can see, the metrics have improved as compared to the previous model which was implemented with the default parameters.
Next, we looked at some metrics on which we should focus to evaluate our model. Precision, which is the total number of positive values out of the guessed positive values, and recall, which is the total positive values of the actual positive values, look like good candidates. The F score, which is a harmonic mean of the recall and precision, is what we chose to go with. Accuracy focuses equally on true positives and true negatives, and for our problem, we understood that the identification of the true positives was more important than identifying true negatives. We tried logistic regression on our training and testing data set, and we were able to achieve an improvement over the naive based F score with the weekday target, and but there wasn't any improvement with the weekend target parameter. This was with the default parameters of logistic regression in sklearn. We further tried to fine tune the model with by varying the C parameter, but there wasn't any significant improvement uh, by that. Next, we tried random forest classifier in sklearn ensemble, which creates a random forest for our training data set. Testing with this classifier created better F scores than any previous models, and this was without with the default parameters. When we tried to vary the n estimators hyperparameter from different values from across 10 to 500, we noticed that optimum F scores were achieved at 400 trees for the weekday parameter and 200 trees for the weekend parameter. Again, significant improvement over the previous default parameter values. After that, we varied the maximum features parameter and also discovered that there were at certain points we had better scores. Finally, we saw that the fine-tuned random forest model performed far better than anything else. This is a comparison of all the values. We can see the naive based classifier the random forest tuned classifier performs almost twice as better as the naive based untuned classifier. So there's a steady improvement in across the models that we've tried.
As you can see, the random forest that to the tuned one outperforms all the other models which we had built previously. So we conclude by saying that the random forest with n estimators 400 and max features 37 gave us the optimal solution for the target variable weekend consumption, and the random forest with n estimators is equal to 200 and max features as 33 gave us the optimal predictions for weekday consumption. Thank you. You could find the link to our final report in the description below.